Assalamu alaikum and greetings everyone. My name is Tamjidur Rahman, metric number 60068. My supervisor is Associate Professor Dr. Abu Saleh Ahmed. My topic is influence of butanol as additive for diesel Karanja biodiesel blend. Here are the contents of my presentation. Introduction, problem statement, objective, from literature, methodology, results, expected influence of butanol, discussion, conclusion, and question answer. Here is the introduction. Fossil fuel is the primary source of energy with very high demand and popularity, but it has a higher risk of extinction, and thus many groups are working very hard to find an alternative source of energy. Biodiesel or methyl esters of fatty acid is a renewable source of energy that is produced from a process called transesterification, which is done in the presence of a catalyst by the mixing of vegetable oil with alcohol. Diesel and biodiesel have very similar properties, and the engine performance with the use of biodiesel is also very noteworthy. Here are the problem statements. The non-renewable sources of energy are depleting at a very higher rate, whereas the demand for the fossil fuel is increasing very acutely, and as a result we can see that the price of fossil fuel is getting higher every day. The emission of greenhouse gases by fossil fuel can cause global warming. Compared to the conventional diesel, biodiesel gives very lower power output. The supply of huge amount of raw material to produce biodiesel is a big challenge. Here are the objectives. Number one, to produce biodiesel from crude Karanja oil using transesterification reaction. Number two, to analyze the performance of the diesel engine using Karanja biodiesel as a fuel. Number three, to produce blends of Karanja biodiesel and additive butanol. Number four, to use different blends of diesel and Karanja biodiesel and compare the performance of the diesel engine. From literature we get Karanja belongs to the family of Leguminosae. Karanja grows up to a height of 15 to 20 meters. Biodiesel are the methyl esters of fatty acids. The oil crops or seeds like mustard, soybean, palm, Karanja and Jatropha gives the highest yield of biodiesel. Biodiesel are carbon dioxide neutral. Biodiesel extensively reduces the greenhouse gases. And finally, here we have got the formula that we have used for the production of biodiesel. Methodology. First, we have done the titration to find the acid value, and we have used this formula to find the acid value. And further, we have done the transesterification method to produce the biodiesel. We have used this equation here to produce the biodiesel. Moving on, next we have the engine power output. To find the engine power output, we multiply the voltage with the current divided by 1000, and then we have got the brake specific fuel consumption, BSFC. To find the BSFC, we divide the fuel flow with brake horsepower, and finally we have the mechanical efficiency. Mechanical efficiency is equal to the brake horsepower divided by the indicated brake horsepower times 100%. Now the results. We have found that the FFA value is 0.684%, which is less than 1%. Thus we continue with one step transesterification method to produce the biodiesel. Later we have the effect of the ratio of catalyst to oil. We have seen that 1% concentration of the catalyst gives the highest yield of the biodiesel, and the effect of methanol to oil ratio, here we have got 9:1 methanol to oil ratio gives the highest yield of biodiesel. So moving on with the results, or I should say expected results, we have the FTIR for both diesel and biodiesel. The infrared spectrum for both the fuel are identical, and the presence of oxygen functional group for Karanja biodiesel is confirmed, which gives less emissions. We can see that here we have the CO functional group and here we have the CN functional group for the Karanja biodiesel. Here CO functional group helps in the reduction of carbon monoxide and CN functional group actually helps in the production of nitrogen. Okay, moving on with the results, we have the densitymeter test where we can see that the density of Karanja biodiesel is in between the densities of crude Karanja oil and conventional diesel. And similar results are found for the flashpoint temperature of Karanja biodiesel, which is in between the flashpoint temperatures of crude Karanja oil and conventional diesel. But the calorific value for the Karanja biodiesel is actually the least when compared between the crude Karanja oil and the conventional diesel. Further, we have the graphs for the speed versus fuel blends and the BSFC versus fuel blends. From the speed versus fuel blends graph, we can see that for B10, we get the highest speed for the engine, which is 1490.33 rpm. And again, for B10, we can see that the fuel consumption is the least when compared between all the other blends. Further moving on, we have the BHP versus the fuel blends, where we can see that for B10, the brake horsepower is the highest, which is 35.3 kilowatts, and also the efficiency for B10 is the highest among all the blends, which is 61.07%. Now, to understand the expected influence of butanol, we have used this study where in this graph the yellow bars represent the neat biodiesel and the red bar represents the butanol added biodiesel. Due to lower calorific value, the BTE, here is the graph for BTE versus the engine load. So the BTE for butanol added biodiesel is way less than the neat biodiesel, and it is the same for all the engine loads. Furthermore, due to the lower energy content, fuel consumption for butanol added biodiesel is actually the highest among all the other fuel blends that has been tested in this study. And however, it can be seen that for higher engine loads, the fuel consumption of all the fuels actually less for when compared to lower engine or in lower engine loads. Again, we can see that due to higher ignition delay, the carbon monoxide emissions for butanol added biodiesel is actually much more higher than the neat biodiesel. However, due to the higher latent heat of evaporation for the butanol added biodiesel, the emissions of nitrogen oxides are actually less when compared to the emissions of neat biodiesel. Now for the discussion, it can be said that the presence of CO functional group from the FTIR test results in the reduction of greenhouse gases, while the CN functional group helps in the production of NOx for the biodiesel. From the results of engine load, SFC, BHP and efficiency, it can be concluded that the B10 blend shows the best performance among all the blends prepared. Due to lower calorific value, lower energy content, higher latent heat of evaporation, and higher ignition delay, the use of butanol as an additive has a negative effect on the engine performance and emission properties of the biodiesel. Now to conclude, we can say that this research has successfully investigated the potential of crude Karanja oil as a sustainable feedstock. B10 showed the best performance among all the blends tested. Use of additive butanol reduce the engine performance of the biodiesel blends. Other than nitrogen oxide emissions, butanol increased all other emissions. Well, that's all from me. Thank you so much.